And it just has such a great effect on uh, on your reliability, on the reliability of your software. The other thing that I noticed was also in terms of maintainability and like, testability, like the dependency injection, like dependency management as well. It's just so great with Effect. I don't have to worry about mocking things extensively. I just build a fake dependency and provide that instead of the real one, the live one. And I feel like I'm much more incentivized to write unit tests. And I don't know how other people think about engineers at companies like Zendesk and like Facebook and Google, like big companies, like how they deal with these things on a day-to-day basis. In the end, like it doesn't matter how skillful or experienced you are, it comes down to incentives all the time. Like you do things that you are more incentivized to do. So if a language or a framework or a library makes something really easy to do, you will do it regardless whether it's the right thing to do or the wrong thing to do. It's just like this. I don't know if there's like a law for this, but it's definitely a psychological effect.
This is one of my favorite paradigms or guidelines in programming or in life in principle, which is like make the right thing easy. And that is, I think, Effect makes some really hard things that are the right thing as easy as they can be, and so easy that it's fun. Doing things like error handling or structuring the hierarchy of your program in a nice way, in the as nicest way as you could possibly do it in TypeScript, that's a huge lift. And that's what Effect enables you. And I think something like dependency injection, that's probably, if you're in your Effect adoption journey, that typically happens sort of like maybe in the second week when you're using Effect after you've like rewritten a whole bunch of like promise code, etc. Maybe you've now like finally cleaned up some of your tech debt around error handling. And then you realize, okay, there's still like some global state we mutate to kind of pass things around, or we just have like this big blob of like properties we're like kind of pulling through like all of our function invocations. Or maybe we have this like monstrous context object, which maybe has a whole bunch of like either it's untyped or it has a whole bunch of like nullable properties, and you kind of pray that it's there. That's like all like semi-principled. I'd argue this the most principled approach about that is like having like a bag of properties that you just like lift through your function calls. But Effect gives you the best of both worlds. It gives you a very principled approach and a very convenient approach. And I think dependency injection has kind of a bad rap. I've used it in various programming languages. I've used it like a lot of in PHP in the past. I've used it like in Golang and other programming languages. It felt like, okay, this is how things should kind of, there is a solution somewhere there, but all the solutions I've used so far were kind of like had such big foot guns that at some point I said like, okay, no, I've hurt myself too much with that. I'll do it manually. And I think Effect finally gives you the cake and lets you eat it. And I think that's really hard to explain. And I think you have to build a little thing, refactor it, and like then throw in a little bit of like type safe context, which is all there is to it, really. It's like React context, but type safe and much nicer. So that's, I think, something you have to try for yourself to see that how nice it is. But I agree, this is one of the best things about it.
Yeah, absolutely. And why does it have a bad rap? But if I think about it, I think it's again comes down to incentives. If the language makes it hard to do dependency injection, because it's never just a singular case like, oh, I'm going to do dependency injection on this function, and this one function will be, the written the right way. Well, your program usually has a certain depth. Like there's like a function, and then that function calls out other functions. Those functions call out other functions, and then the dependency needs to travel all the way down because it's called somewhere at the leaf. For example, a database call is made somewhere at the leaf of your program. And wiring through all these layers and then adding the dependency in the list of arguments all the time, well, I'm not surprised that people get tired of it. And I started thinking about it a few weeks ago, like, what are these approaches? And I started calling them just internally for myself, for my own sake. Like, there's this explicit dependency injection where you like have to do all the wiring like yourself. Then there's some languages like Scala, which somehow give you like some language features which allow you to implicitly wire through
Right. You
these
need to
things.
have a big brain for that.
And it feels a little bit magical, right? This implicit dependency injection. I don't know if it's through traits or something. I'm not a big Scala user, but I did see some of it. And then you have effect, which is like, it's somewhere in the middle. Like it's kind of implicit, but it's also very explicit in a sense. Like you do declare, you see where you inject the dependency by providing the implementation. And then you also see the place where you're calling the functions and the stuff that's on the dependency, because you have to yield it, or yield star. So it's kind of implicit because you don't have to wire it manually. You just use it at the site where you need it.
I think it's the best of both worlds in a very similar way how I think TypeScript is the best of both worlds, where it very elegantly does type inference in most places where you can. A lot of static languages like ask you to write type annotations everywhere. And that I think also causes like some fatigue when you use a typed language. And I think TypeScript makes it so nice that you can get away with like just type annotations in the minimum amount of places, sometimes even for argument types if you have a default value, for example. So most things where possible can be inferred, and that's totally fine. And so think about the context, the type dependencies of an effect of a function. Think about it the same way as like if it's used, it can be inferred. If you return something from a function that looks like an object with a property user, then the type can be inferred. That's because you return it. And what's so cool about effect is like if you use a thing in a function and using, like you said, like if you yield something, so the equivalent of like an await, then effect and like A on the type level wires things up nicely with TypeScript, that in the type signature you say like, aha, here we need the database client. And also during runtime, makes sure, like, okay, there's behind the scenes a context object where we have the database client, so it picks it up. And not just even that, but also when you finally get to run your program, it makes sure that at some point you supply your database client. And I think that is so elegant when you use it. But it's hard to kind of grasp it if you haven't taken a look at that with code and like try to refactor a little something. But I agree, it's one of the most elegant things about effect.